Good day everyone, and welcome to where we are putting together solutions to those additional mathematics questions. And in this video, we'll be specifically looking at section 2 of the syllabus, coordinate geometry, vectors, and trigonometry. This video focuses on from May 2012 until 2016. Don't forget to like the video and add any comments down below so we can make other videos to help you in whichever areas that you are struggling with. If you look at the description down below, you'll get an overview of the entire structure of our channel, so you can follow along to cover all the past paper questions in this subject. As we look at the four major sections of additional mathematics, this video looks at section 2, coordinate geometry, vectors, and trigonometry. This section is tested for 15 marks in paper 1, or 15 multiple choice questions, and in paper 2, the long paper, which is worth 100 marks, it is tested for 20 marks. This section is subdivided into 3 parts: coordinate geometry, and coordinate geometry can be subdivided into finding the equation of a straight line and its gradient, parallel lines and perpendicular lines, equation of a circle, its center and radius, equations of a tangent and normal, point of intersection between two straight lines, just as the CSEC Maths syllabus was, or a straight line and a circle. The second subsection is vectors, which can be subdivided into 2D vectors and their geometric representation, equality and unit vectors, position and displacement vectors, modulus and direction of a vector, scalar or dot product of two vectors, and parallel and perpendicular vectors. The final subsection is trigonometry, where we'll be looking at arc length and area of a sector, sine, cosine, and tangent, the trigonometric ratios of the angles 0, pi on 6, pi on 4, pi on 3, pi on 2, 2 pi on 3, 4 pi on 3, and 2 pi, where of course pi is in radians, compound angle formulae, double angle formulae, trigonometric equations including graphs. And if you look at an overview of how this section was tested, we can see that coordinate geometry and vectors combined for number 3 in all 5 years, and the trigonometry was question number 4. This should make it easier for students to subdivide and study by topic. May 2012, number 3a. The equation of a circle is given by x squared plus y squared minus 4x plus 6y is equal to 87. Part 1. A line has the equation x plus y plus 1 is equal to 0. Show that this line passes through the center of the circle. So let's rewrite the equation. X squared minus 4x plus y squared plus 6y is equal to 87. So we're keeping the x's together and the y's together. Let's see if we can complete the square using the x's only. So let's recall x squared minus 4x plus, what is half of that coefficient which we have in red? Minus 4. Well, that will be minus 2. So we'll say minus 2 squared minus minus 2 squared. So we're adding these and subtracting the same amount. So we're not actually changing it. And we'll do the same thing with the y's. And we have the coefficient of y in green. So that means plus y squared plus 6y plus half of 6 is 3 squared minus 3 squared is equal to 87. We can now complete the square by saying x squared minus 4x plus minus 2 squared. And let's see for the minus 2 squared outside. And let's do the same thing for the y. So we're going to get y squared plus 6y plus 3 squared minus 3 squared is equal to 87. We can work out what's outside the bracket. So we write x squared minus 4x plus minus 2 squared minus 4. And we can simplify the square bracket. So that will give us x minus 2 squared minus 4 plus y plus 3 squared minus 9 is equal to 87. And we can carry the minus 4 and minus 9 across. So that will give us x minus 2 squared plus y plus 3 squared is equal to 87 plus 4 plus 9, which works out to be 87 and 4 is 91. 91 plus 9 is 100. So we can rewrite the line, and the right hand side will be equal to 100 or 10 squared. The center is, since we have the first bracket x minus 2, therefore x is equal to 2, and the y coordinate of the center will be y is equal to minus 3. And r squared will be on the right hand side. R squared is equal to 10 squared. As such, the radius of the circle is equal to 10. If you want to show that the line x plus y plus 1 is equal to 0 passes through the center, then you can substitute the x and y values. So x plus y plus 1 is equal to, we know x is 2, plus y is minus 3 plus 1, and that works out to be 0. As such, the line passes through the center of the circle. Part 2. Find the equation of the tangent to the circle at the point A minus 6, 3. So let's sketch the circle. Let's first put the center 2 minus 3 onto a sketch, and the radius is 10, which means that one point on the circumference would be minus 3 plus 10, which is 7. So one point would be 2, 7. That's 10 right above it. And similarly, we'll have 10 vertically below it. So it'll be minus 3 minus 10, which is minus 13. And then the point to the right, we'll be adding 10 to the x-coordinate. So it'll be 12 minus 3. And the point to the left, we'll be minusing 10 from the x-coordinate. So it'll be minus 8 minus 3. So we can connect the dots, and that gives us our circle with center 2 minus 3 and radius 10. Now we want to find at the point A, which is minus 6, 3. So let's draw a line called the normal from the center to that point. And if we want to find the equation of the tangent, that will be the brown line, which means it's perpendicular to the normal. We can find the gradient of the normal, which is change in y over change in x. And we know it as y2 minus y1 over x2 minus x1. So the change in y would be 3 minus 3, because we're moving from A, that point on the circumference, to the center, over minus 6 minus 2. And 3 minus minus 3 is 6 over minus 6 minus 3 is minus 8, minus 6 over 8, or minus 3/4. Since the gradient of the normal works out to be minus 3/4, and the normal and the tangent are perpendicular to each other, it means the gradient of the normal times the gradient of the tangent is equal to minus 1. So we can substitute minus 3/4 times the gradient of the tangent is equal to minus 1. So mt, the gradient of the tangent, is equal to 4/3. And now we can find the equation of the line. Since we know that the equation is equal to change in y over change in x, we can substitute. And that will give us 4/3 is equal to y minus, what's a point on the tangent? Minus 6, 3. So we'll use those coordinates. So we'll get y minus 3 all over x minus 6. And we can take the denominator on the right hand side and carry it across. So it gives us 4/3 times x plus 6 is equal to y minus 3. We can now expand the brackets and carry the minus 3 across. So we're going to get 4/3 x plus 4/3 times 6 plus 3 is equal to y. As such, y is equal to 4/3 x plus 11. And that's the equation of the tangent to the point A. And we can see from our sketch that the gradient of the tangent is positive, because the coefficient of x, which represents the gradient, is positive. May 2012, number 3b. Given that the vector OA can be represented as A, OB represented as B, and AP is equal to half OA, where A is equal to 2, 1, and B is equal to 3, 2. Part 1. Write BP in terms of A and B. So this falls under the topic of vectors, and we found for students who are struggling, the best thing to do is make a sketch. So if we bring up a point O randomly, and we know if we're going to A is 2, 1, which means 2 to the right and 1 up. So you can approximate where A will be. So OA will give us that arrow moving to the right. And then we know B is 3, 2. So if we're starting from O, we're moving more to the right and higher up. So we bring that up with a blue X, and we'll draw that line OB to represent small b. And we also know that AP is equal to a half OA. So it means it's half the length of OA and moving in the same direction as OA. But it's starting at A. So it's going further to the right. And that will give us B. So now that we have this sketch, we want to look at BP. So how do we move from B to P? We can move from B to O, plus O to A, plus AP. And after we write that vector sentence, let's now adjust because we don't know BO, but BO is equal to minus OB. So we can rewrite it BP is equal to minus OB plus OA plus a half OA. And we can substitute. So BP is equal to minus B plus A plus half A. So that is BP is equal to minus B plus 3 on 2A. Find the modulus of BP, which means the length of BP. So BP we know is minus B plus 3 on 2A, and we can substitute for A and B here. So BP is equal to minus 3 on 2 plus 3 on 2 by 2 on 1. So that works out to be, if we look at the x values, minus 3 plus 3 on 2 times 2, 2 cancels 2, so left with 3. So minus 3 plus 3. And the y value is minus 2 plus 3 on 2 times 1 is 3 on 2. So minus 3 plus 3 works out to be 0. And minus 2 plus 3 on 2, or 1.5, is minus a half. So now that we know BP means that we're moving 0 in the x direction. So neither moving right or left, but we're moving minus a half down. Then the length of that will be 0 squared plus minus a half squared is equal to a half units. May 2012, number 4A. The diagram shows a sector of a circle center O with an adjoining square. The radius of the circle is 4 meters, and we can see that as OC and also OA. If the sector AOC subtends an angle pi on 3 at O, and you can see that in the diagram as well, calculate, giving your answer in terms of pi. Part 1. The area of the shape OACMN, the entire shape. So we can consider this to be a compound shape where we have the area of the sector above and the area of the square. So we can write that area of the entire shape OACMN is equal to the area of ACMN and area of OAC. And the area of OCMN is a square with side 4 or R. So that will be R times R or R squared. Plus the area of the sector is a half R squared theta. So since we have a formula, we can substitute and solve. So the area of the entire shape is equal to, what is R? 4. So 4 squared plus a half times 4 squared times pi on 3. And that will give us 16 plus 4 4s are 16, 2 into 16, 8. So plus 8 pi on 3. So the entire area is 16 plus 8 pi on 3 meters squared. And part 2, find the perimeter of the shape OACMN, the entire shape. So the perimeter of a compound shape would just be to add up all the sides. So the perimeter is equal to A to O plus ON plus NM plus MC plus CA. So we're starting on top and moving to the left and going right around. So AO is equal to 4 plus ON, which is another 4, plus NM is a 4, and MC is also 4 meters, plus CA, the length of the arc. And the formula for length of arc is R theta. So we can substitute, and that will give us 4 plus 4, we have 4 4, so that will give us 16 plus R is 4 and theta is pi on 3, so 4 pi on 3. As such, the perimeter is 16 plus 4 pi on 3 meters. May 2012, number 4B. Given that sine pi on 3 is equal to root 3 on 2, and we know pi is equal to 180 degrees, so 3 into 180 is 60. So sine 60 is equal to root 3 on 2. It's just another way of saying it. In this case, they're using the units of radians rather than degrees. And cos pi on 3, which is cos 60, is equal to a half. And sine pi on 4 is equal to cos pi on 4, which is equal to root 2 on 2. evaluate, without using calculators, the exact value of cos 7 pi on 12. Cos 7 pi on 12 can be broken up into cos 3 pi on 12 plus 4 pi on 12. And the compound angle rule for cos A plus B is equal to cos A cos B minus sin A sin B. So we can apply that here. So that's going to give us cos 3 pi on 12, cos 4 pi on 12, minus sin 3 pi on 12, sin 4 pi on 12. So we can simplify. So that will give us cos 3 pi on 12 is cos pi on 4, 3 into 3, 1, 3 into 12, 4. And 4 pi on 12 will give us pi on 3. So it will give us cos pi on 4 times cos pi on 3 minus sin pi on 4 minus sin pi on 3. And you can simply substitute. So that will give us root 2 on 2 times a half minus root 2 on 2 times root 3 on 2. And we can see that the denominator is 4 in both cases. So we can now factorize out root 2 over 4, and we're left with 1 minus root 3. Part C. Prove the identity 1 on sec theta plus tan theta is equal to 1 minus sin theta cos theta. And we can use either side, so let's use the left-hand side. The left-hand side says 1 on sec theta plus tan theta. Sec theta is 1 over cos theta, so we can substitute. So we're going to 1 all over 1 over cos theta plus, and what is tan theta? Sin theta over cos theta. And we can simplify that fraction below. So it will give us 1 over 1 plus sin theta all over cos theta. And since we're just manipulating fractions here, that can be written as 1 divided by 1 plus sin theta over cos theta. And if we're dividing fractions, of course, it means to multiply and define the reciprocal. So it will be 1 times cos theta over 1 plus sin theta. So that gives us cos theta over 1 plus sin theta. And now if we multiply the numerator and denominator by the same terms, then that means the value remains unchanged. So we can do that. So cos theta over 1 plus sin theta times 1 minus sin theta over 1 minus sin theta. So the numerator will give us cos theta by 1 minus sin theta, and the denominator will be 1 plus sin theta by 1 minus sin theta is 1 minus sin squared theta. Similar to a plus b by a minus b is equal to a squared minus b squared, the difference of squares. And of course we know 1 minus sin squared theta is equal to cos squared theta, so you can replace that. So it'll give us cos theta by 1 minus sin theta all over cos squared theta. And we can cancel cos theta from above and below. So we're left with 1 minus sin theta over cos theta, which is equal to the right hand side. So we have proven the trigonometric identity. May 2013, number 3A, part 1. A circle C has center with coordinates A, 2, 1, and passes through the point B, 10, 7. So let's bring up a little sketch where we randomly put x as being 2, 1 and let B as 10, 7. And we can draw a line from one to the other. And let's draw a dotted circle to show where this falls, as C is the center and B is the point on the periphery. So express the equation of the circle in the form x squared plus y squared plus hx plus jy plus k equal to 0, where h, g, and k are integers to be determined. So first of all, let's consider the right angle triangle from the center to B. And if we consider the change in x, we're moving from 2, the x coordinate, to 10. So the change in x is equal to 8. And we're moving in the y direction from 1 to 7. So the change in y is equal to 6. If we're using Pythagoras' theorem, delta x squared plus delta y squared is equal to r squared, the length of the hypotenuse. So we can substitute and we get 8 squared plus 6 squared is equal to r squared. 8 squared is 64 plus 6 squared is 36. 64 and 36 is 100. So we can say 10 squared or 100 is equal to r squared. So we found the radius of the circle to be 10. And our general formula for a circle, x plus f all squared plus y plus g all squared is equal to r squared. And f and g would be the coordinates of the center. So we'll have x minus 2 all squared plus y minus 1 all squared is equal to 10 squared. And this is the equation of a circle, but it's not in the form that we want. So let's expand it. So it's going to give us x squared minus 4x plus 4 plus y squared minus 2y plus 1 is equal to 100. And if we move the 100 across, then we'll get into the form that we want. X squared plus y squared minus 4x minus 2y minus 95 is equal to 0. Part 2, the line L is a tangent to the circle C at the point B, which is 10, 7. Find an equation for L. And we have that tangent as a green line there. So let's recall that the gradient of the normal, which we have in red, is change in y over change in x, and we already have those values, which will be 6 over 8. So the gradient of the normal is 3/4. And since it's sloping to the right, it agrees with this, that is positive, so it's plus 3/4. And the gradient of the normal times the gradient of the tangent, since they are perpendicular to each other, will be minus 1. And we can substitute. So 3/4 times the gradient of the tangent is equal to minus 1. As such, the gradient of the tangent, mt, is equal to minus 4 over 3. And if we want to find the equation of the green line which is L, then mt is equal to change in y over change in x, and we can substitute. So the gradient is minus 4 over 3 is equal to y minus, what's the y coordinate of b? 7, over x minus, what's the x coordinate? 10. And we can now carry the denominator across to the left-hand side. So it will be minus 4 over 3 times x minus 10 is equal to y minus 7. And we can expand and carry the minus 7 across. So it will give us minus 4/3 x plus 4/3 10 plus 7 is equal to y. So y is equal to minus 4/3 x, and 4/3 of 10 is 40 over 3 plus 7, which is 21 over 3, so that's 61 over 3. So the equation of the green line is y is equal to minus 4/3 x plus 61 over 3, or 20 and 1/3. And if you look at the green line, we can see it's sloping downwards. As such, the gradient should be negative. And if you notice in our answer that the coefficient of x, which is the gradient, is negative 4/3. May 2013, number 3b. The position vectors of 2 points P and Q relative to a fixed origin O are 10i minus 8g and lambda I plus 10g, respectively, where lambda is a constant. So we can clearly see that this falls under the subtopic of vectors. Find the value of lambda such that OP, that vector, and vector OQ are perpendicular. So if we're using the scalar product, also known as the dot product, then we can say that OP dot OQ is equal to the length of OP times the length of OQ, or mod OQ, cos theta. And we know that theta is 90 degrees. As such, cos 90 works out to be 0. So the whole right-hand side of this equation will be equal to 0. So we can rewrite it substituting the correct values. 10 minus 8, because OP was 10i minus 8j, dot lambda 10, because OQ is equal to lambda I plus 10j, is equal to 0. And if you remember the dot product, if we have A1, B1 by A2, B2, we multiply the top and then we multiply the base and add them. So that will give us 10 lambda plus minus 8 times 10 is equal to 0. 10 lambda is equal to 80. As such, lambda is equal to 8. So when lambda is equal to 8, such that OQ is equal to 8i plus 10j, then OP and OQ are perpendicular to each other. Part C. The position vectors of A and B with respect to a fixed origin O are given by OA is equal to minus 2i plus 5j. So we can make a little sketch. Let's bring up an X to indicate where O is. And if OA is minus 2i, that means it's moving minus 2 in the X direction. So it's moving to the left, and then it's moving up 5 units. So we can get an average of where A is. It doesn't have to be exact, but give us a general idea. And OB is equal to 3i minus 7j, respectively. So that indicates that it moves 3 to the right and 7 units down from O. So we have OA and OB. Find the unit vector in the direction AB. So if we're going from A to B, vector AB, it means we can pass from A to O. Remember, our starting point will be A. And then we're going from O to B. Now we don't have AO, but we have OA. The difference between them is the direction. So we can rewrite it, AB is equal to minus OA plus OB. And we can substitute values, so AB is equal to minus 2, 5 plus 3 minus 7. And we can work it up, minus 2, that's 2 plus 3 is equal to 5. And the base, minus 5 plus minus 7 is minus 12. The vector AB means that we're moving 5 units in the x direction, or 5 units to the right, and 12 units downwards. And we can see that from our diagram. Now we want to find the unit vector. So in order to do that, we must first find the length of AB. So if we're using Pythagoras' theorem, and let's indicate that by bringing up a blue right angle triangle, then we know the length of the triangle, or the hypotenuse, AB squared, is equal to the sum of the squares of the two shorter sides. So that will be equal to 5 squared plus minus 12 squared, because we already knew to go from A to B means we're moving 5 in one direction and minus 12 in the other. And we can work that out. 5 squared is 25 plus minus 12 squared is 144. So 144 plus 25 is equal to 169. That's AB squared. As such, the length of the vector AB is equal to the square root of 169, which is 13. We want to find the unit vector in the direction AB. So let's indicate that. That will be the actual vector divided by its length. So unit vector of AB is equal to 5i minus 12j all over 13. May 2013, number 4a. The diagram shows a sector cut from a circle center O. The angle at O is pi over 6, which clearly means that it is in radians. And if you wanted to convert it to degrees, pi is equal to 180 degrees divided by 6, so it's indicating that it's 30 degrees. So the angle at O is pi on 6. If the perimeter of the sector is 5 on 6 times 12 plus pi centimeters, what is its area? In order to find the perimeter of a shape, we need to add up all the sides. So the perimeter is equal to the radius plus the radius plus the length of that arc, which is r theta. And we know perimeter, 5 6 by 12 plus pi, that was given, is equal to r plus r, which is 2r, plus r times pi on 6. And if we expand the left-hand side, we're going to get 5 6 times 12, 6 into 6, 1, 6 into 12, 2, 2 5s are 10. 10 plus 5 pi on 6 is equal to 2r plus r by pi on 6. As such, r is equal to 5. So we know the radius. And we can now find the area of the sector. Area of a sector is equal to half r squared theta, which is equal to half times, we know r, that's 5 squared times pi on 6. So 5 5s are 25. So that will give us area is equal to 25 pi over 12 square units. Part B. Solve the equation 2 cos squared theta plus 3 sin theta is equal to 0. For 0 is less than or equal to theta, which is less than or equal to 360 degrees. So for one revolution. So clearly this is a trigonometry question. Let's see if we can solve. So let's rewrite the equation 2 cos squared theta plus 3 sin theta is equal to 0. And we know that sin squared theta plus cos squared theta is equal to 1. As such, cos squared theta is equal to 1 minus sin squared theta. So we can substitute that. So we're going to get 2 times 1 minus sin squared theta plus 3 sin theta is equal to 0. And we can expand, so it's going to give us 2 minus 2 sin squared theta plus 3 sin theta is equal to 0. So let's rearrange. We're going to get minus 2 sin squared theta plus 3 sin theta plus 2 is equal to 0. And for some students who are struggling and not seeing it, we can remove the minus sign by multiplying throughout, both on the left and right, by minus 1. So the equation now becomes 2 sin squared theta minus 3 sin theta minus 2 is equal to 0. Some students can work it using the line above, some are getting problems, so we can change it to this form. And it has the same meaning. So now we have a quadratic equation, we can factorize it. So it is going to give us 2 sin theta plus 1 by sin theta minus 2 is equal to 0. So if we need to solve this quadratic, then either of the brackets will be equal to 0. So either sin theta minus 2 is equal to 0, which means sin theta is equal to 2. And if you remember the sine graph, the maximum or minimum values of sine theta is plus and minus 1. As such, theta is not possible to get an answer where sine theta is equal to 2. So since the first bracket doesn't work out to be 0, then clearly the second bracket must be. 2 sine theta plus 1 is equal to 0. So 2 sine theta is equal to minus 1. Sine theta is equal to minus a half. As such, theta is equal to 210 degrees and 330 degrees. Remember that sine theta is equal to a half means that theta is equal to 30 degrees. But since it's negative, remember that for the 4 quadrants, all school teachers' cuts means that for sine theta to be negative, it's either in the 3rd quadrant or the 4th quadrant. If it's in the 3rd quadrant, it will be 180 plus the 30, which is 210. And if it's in the 4th quadrant, it's 360 minus 30, which is 330 degrees. Part C. Given that tan theta minus alpha is equal to a half, and that tan theta is equal to 3, use the appropriate compound angle formula to find the value of the acute angle alpha. And of course, this is a trigonometry question as well. So let's rewrite it. Tan theta minus alpha is equal to, using the compound angle, tan theta minus tan alpha all over 1 plus tan theta tan alpha. And we can substitute what we know. We know the left-hand side is equal to a half. That's given in the first line. And that's equal to 3 minus tan alpha, because tan theta is equal to 3, all over 1 plus 3 tan alpha. And if we look at the equation, we only have one unknown, so we just need to rearrange, making tan alpha the subject of the formula. So we can carry the denominators across on either side. So it'll be 1 times 1 plus 3 tan alpha is equal to 2 times 3 minus tan alpha. And we can expand the brackets. So it's going to give us 1 plus 3 tan alpha is equal to 2 3s are 6 minus 2 tan alpha. And let's carry all the tan alphas across on the left hand side. So it's going to give us 2 tan alpha plus 3 tan alpha is equal to 6 minus 1. So 5 tan alpha is equal to 5. As such, tan alpha is equal to 1. So alpha is equal to 45 degrees. Remember, alpha is an acute angle. May 2014, number 3A, part 1. Determine the value of k such that the lines x plus 3y is equal to 6 and kx plus 2y is equal to 12 are perpendicular to each other. So, of course, this falls under coordinate geometry, and we're looking at lines of intersection. So let's write the first line. X plus 3y is equal to 6. So 3y is equal to minus x plus 6. As such, y is equal to minus 1/3 x plus 6 over 3, which is 2. Therefore, we can tell from this first line that the gradient of that line, m1, is equal to minus 1/3. Remember, the gradient is the coefficient of x. And for the second line, kx plus 2y is equal to 12. So we can rearrange as well to make it look like a straight line graph. Then we're going to get 2y is equal to minus kx plus 12. Y is equal to minus k on 2, x plus 6. So the gradient of the second line is minus k over 2. Now that we know that, let's recall that since the lines are perpendicular, if we multiply the gradients, m1 times m2, it's going to give us minus 1. And we know m1, so we can substitute minus 1/3 times minus k over 2 is equal to minus 1. And that means that if we carry everything across, we're going to get k is equal to minus 6. So we solve for k. Part 2. A circle of radius 5 centimeters has its center, the point of intersection of the two perpendicular lines in part 1. Determine the equation for this circle. So let's recall that the first equation, minus 6x plus 2y is equal to 12, because we know k is minus 6. And we can substitute for y, because we worked out y is equal to minus 1/3 x plus 2 in the first part of part 1. So that's going to give us minus 6x plus 2 by our substitution, which is minus 1/3 x plus 2, equal to 12. And we can expand and solve because we have only one unknown, which is x. So minus 6x minus 2/3 x plus 2 2s are 4. We can carry the 4 across. That will give us 12 minus 4. So minus 6x minus 2/3 x. Minus 6x is minus 18 on 3. Minus 2 on 3 is minus 20 on 3. X is equal to 12 minus 4, which is 8. So if we want x, we can carry the minus 20 on 3 across. So it will be 8 times minus 3 on 20, which will give us minus 24 on 20, or minus 6 on 5. So we found the x coordinate for the point of intersection. And if you want to find the y coordinate, let's just substitute into the equation. So y is equal to minus 1/3 x plus 2, and we know x. So y is equal to minus 1/3 by minus 6/5 plus 2. The minuses cancel, 3 into 6, 2. So we get 2/5. So y is equal to 2/5 plus 2, which is 12/5. And since we know the center of the circle, then we can substitute into the general formula x plus f squared plus y plus g squared is equal to r squared. Remember, this is the formula that's given. And we know that it's cutting at minus 6/5. So x plus 6/5 all squared plus y minus 12/5 all squared is equal to 5 squared. Remember, in part 2, the first line, they told us the radius was 5. So we can expand and simplify. So you're going to get x squared plus 12/5x plus 36/25 plus y squared minus 24/5y plus 144/25 is equal to 25. So we can carry everything across to make it equal to 0. So it's going to give us x squared plus 12/5x plus y squared minus 24/5y minus 445/25 equal to 0. And if we look at the sketch below, we can see the circle where its center is minus 6/5 or minus 1.2, where the y value is 12/5 or 2.4, and the radius is 5. And we have the lines x plus 3y is equal to 6 and kx plus 2y is equal to 12. May 2014, number 3b. RST is a triangle in the coordinate plane. Position vectors R, S, and T relative to an origin O are 1, 1, 3 minus 1, and 4, 4 respectively. Let's bring up a little sketch. And since R is 1, 1, let's average where R is. Let's bring up our X to show that point. And S is 3 minus 1, so it's to the right of O, but below the x-axis. And 4, 4 means T is 4 to the right and 4 up, so it's in the first quadrant. Show that TRS is equal to 90 degrees. And let's draw a green line from T to R and one from R to S. So how do we work that out? We know OR is 1, 1, OS is 3 minus 1, and OT is 4, 4. And we want to find TR, the vector that goes that way. Clearly we can see it's moving to the left and downwards. So TR is equal to TO plus OR. And we know OT, so we can rewrite it in that form. TR is equal to minus OT plus OR. And we can simply substitute. So that's going to give us minus 4, 4 plus 1, 1, which works out to be minus 4 plus 1 is minus 3. And minus 4 plus 1 is minus 3. So TR is minus 3 minus 3. Let's do the same thing for RS. So RS is equal to RO plus OS. And we have OR, so we can rewrite it. RS is equal to minus OR plus OS. And simply substitute minus 1, 1 plus 3 minus 1. Minus 1 plus 3 is 2. And minus 1 plus minus 1 is minus 2. So now that we have TR and RS, we can use the dot product or scalar product. So TR.RS is equal to mod TR, which means the length of TR, mod RS, mod means modulus, or length of RS, cos theta. We can substitute, so it's going to give us 2 minus 2 dot minus 3, which works out to be 2 times minus 3, plus minus 2 times minus 3, which works out to be 0. And in order for this to work out to be 0, the length of TR is not 0, the length of RS is not 0, so the only way the right-hand side could be equal to 0 is if cos theta is equal to 0. And if cos theta is equal to 0, that means theta is equal to 90 degrees. As such, we have proven that TR and RS are 90 degrees to each other. So let's bring up a little square indicating such. Part 2, determine the length of the hypotenuse. And we can bring that up with a red line from S to T, because we already know TR and RS are 90 degrees to each other. So in order to figure out ST squared, which is equal to RS squared plus RT squared, we need to first work out what is RS squared. Let's bring up a blue right angle triangle to indicate such. And if you're going from R to S, then using Pythagoras' theorem, that's delta x squared, or change in x squared plus change in y squared. And to move from R to S, we're moving 2 to the right, so delta x is 2, and we're moving 2 down, so delta y is equal to minus 2. And if we substitute, you're going to get r squared is equal to 2 squared plus minus 2 squared. 2 squared is 4 plus minus 2 squared is also 4. So r squared is equal to 8. So similarly, let's work out for rt squared by bringing up a green right angle triangle to move from r to t. And if we want to find the change in x, when we're moving from r to t, we're moving from 1 until 4. So delta x, so the change in x is 3. And we're moving from 1 to 4 in the y direction. So the change in y is also 3. So rt squared is equal to 3 squared plus 3 squared. 3 3s are 9 plus 9 is 18. So we've gotten r squared and we've gotten rt squared. So we can now substitute. st squared is equal to 8 plus 18. So st squared is equal to 26. As such, the length of the hypotenuse, which is st, is equal to the square root of 26. May 2014, number 4a. Figure 1 shows a sector OAB of a circle with center O, radius 9 centimeters, and angle 0.7 radians. Part 1. Find the area of the sector OAB. Formula for area of a sector is equal to half r squared theta. And we know r and we know theta, we can simply substitute. So that will give us a half by 9 squared times 0.7, which works out to be, using our calculators, 28.35 centimeters squared. Part 2. Hence, find the area of the shaded region H. So if you want to find the area of the triangle OAC, then that will be a half OA times AC, because it's a right angle triangle. So it's like saying a half times length by breadth, because length by breadth, OA times AC, is perpendicular to each other. So that will be substituting a half times OA is 9 times AC is 9 tan 0.7. Remember, we have the adjacent, we want to find the opposite. And that simply works out to be 34.11 as the area of the entire triangle. So if we want to find the area of the shaded portion H, then the area of H would be area of the triangle 34.11 minus the area of the sector 28.35, which gives us the area H is equal to 5.76 square centimeters. Part B. Given that sine pi on 6 is equal to half, cos pi on 6 is equal to root 3 on 2, show that cos x plus pi on 6 is equal to a half root 3 cos x minus sin x, where x is acute. So let's use the left-hand side, cos x plus pi on 6, and we can use the compound angle formula. Remember, cos a plus b is equal to cos a cos b minus sin a sin b. So we can expand, and this will give us cos x cos pi on 6 minus sin x sin pi on 6. And we know cos pi on 6 and sin pi on 6, they were given above, so we can substitute. So that's going to give us cos x by root 3 on 2 minus sin x by a half. And we can factorize out the half, so it's going to give us root 3 cos x minus sin x, which is equal to the right hand side. So we have proven the trigonometric identity. Part C. Prove the trigonometric identity. Tan theta sin theta over 1 minus cos theta is equivalent to 1 plus 1 on cos theta. So what I usually do is take the more complicated side and try to simplify. So the more complicated side looks like the left hand side. So let's rewrite the left hand side. Tan theta sin theta over 1 minus cos theta is equal to, and we know what tan theta is, so we can substitute for that. Sin theta over cos theta times sin theta all over 1 minus cos theta. And now it becomes a point of just using fractions. So we can say sin theta by sin theta is sin squared theta over cos theta. And we have the denominator, so we multiply by 1 over 1 minus cos theta. And we know sin squared theta plus cos squared theta is equal to 1. So sin squared theta is equal to 1 minus cos squared theta. So we can substitute for that. So it's going to give us 1 minus cos squared theta over cos theta times 1 by 1 minus cos theta. A squared minus b squared is equal to a plus b by a minus b. Looking at the difference of squares, so 1 minus cos squared theta can be rewritten as 1 plus cos theta times 1 minus cos theta all over cos theta times 1 over 1 minus cos theta. And clearly we have the same brackets in the denominator and numerator, so we can cancel them off. So we're left with 1 plus cos theta all over cos theta. And we can separate it, so it will give us 1 over cos theta plus cos theta over cos theta, which is 1 over cos theta plus 1. which is equal to our right hand side. So we have proven our trigonometric identity. May 2015, number 3a. The equation of a circle is given by x squared plus y squared minus 12x minus 22y plus 152 equal to 0. Part 1. Determine the coordinates of the center of the circle. So let's rewrite the formula and let's put the x's together. So it's going to give us x squared minus 12x plus y squared minus 22y plus 152 is equal to 0. And let's look at the first two terms, x squared minus 12x, and use the method of completing the square. This gives us x squared minus 12x, and we're going to add half of that term we have in red, which is the coefficient of x. So we're going to add minus 6 squared minus 6 squared. So we're adding and subtracting the same term. We're going to do the same thing with the y's. So we're going to have y squared minus 22y plus, what is half of minus 22? Minus 11 squared minus 11 squared plus 152 is equal to 0. So we can now take the first three terms, x squared minus 12x plus minus 6 squared minus 6 squared, and do the same thing there. We're just going to bracket it off. So we're going to get y squared minus 22y plus minus 11 squared minus 11 squared plus 152 is equal to 0. So we can take the first three terms, x squared minus 12x plus minus 6 squared, and when we factorize that, it's going to give us x minus 6 squared minus 36 plus, we do the same thing with the first three terms, y squared minus 22y plus minus 11 squared will give us y minus 11 squared minus 121 plus 152 is equal to 0. So we have x minus 6 squared plus y minus 11 squared, and minus 36 minus 121 is minus 157 plus 152 gives us minus 5 equal to 0. As such, x minus 6 squared plus y minus 11 squared is equal to 5. So we know the center is 6, 11, the x and y coordinates. And if we want to find the length of the radius squared, r squared is equal to the right hand side, which is 5. So r is equal to the square root of 5. So we can bring up a diagram with the center of the circle indicated as 6, 11 and the radius as square root of 5. That's what it looks like. Part 3. Determine the equation of the normal to the circle at the point 410. So let's draw the point 410 and let's draw a normal, which means a line from the center to that point. And we want to find the equation of that green line. So the gradient of the normal m, n let's just say, will be the change in y over change in x. And if we're moving from the y values, we're moving from 11 at the center to the point on the circumference where the y value is 10. So 11 minus 10 all over, what's the x value? At the center it was 6, and on the circumference it is 4. So 6 minus 4. So the gradient n is equal to 11 minus 10, which is 1 over 6 minus 4 is 2. So the gradient is a half. And this makes sense because if you look at the green line, you will see that it's going upwards to the right, meaning that it's positive. And the gradient here is positive as well. Now, if we want to find the equation of the line, we know gradient of n is equal to change in y over change in x, so we can substitute. A half is equal to y minus a point on the line, which is 10, over x minus 4. We could have also used the coordinates of the center as well, and it will still give us the same equation. So we want to make y the subject of the formula. Let's carry the x minus 4 across. So we're going to get a half x minus 4 is equal to y minus 10. So we can expand and carry the minus 10 across to the left. So we're going to get a half x minus 2 plus 10 is equal to y. So y is equal to half x plus 8. And that will be the equation of that green line, the normal to the circle. May 2015, number 3b. The position vectors of 2 points A and B relative to an origin O are such that OA is equal to 3i minus 2j and OB is equal to 5i minus 7j. So let's make a sketch. Let's bring up O. And we know OA is 3i minus 2j. It means it's moving 3 units to the right and 2 units down. So let's just average where A will be. We could draw a line from O to A, indicating that vector. And OB is 5i minus 7j, meaning more to the right. So 5 to the right and 7 down. So we can draw another line indicating OB. And that's just an average, so we get an idea of what's happening. Determine part 1, the unit vector AB. So if we're going from A to B, let's have that in red. And how can we pass from A to B in another direction? We can start from A and go to O, and then from O to B. So that gives us our first line. And we don't know AO, but we know OA. So we can rewrite it AB is equal to minus OA. That's the difference between changing the direction, putting a negative sign, plus OB. And we can now substitute the values. So it's going to give us minus 3 minus 2 plus 5 minus 7. Minus 3 plus 5 is 2. And minus 2 is 2, plus minus 7 is minus 5. So AB is 2 minus 5. And from our sketch, we can see if we're moving from A to B, we're moving to the right. So that's 2 and moving 5 units down, minus 5. And if you want to get a unit vector, we need to find the length of AB. So let's bring up a right angle triangle there in blue. And we want to find the length of AB. It's just like using Pythagoras' theorem. So AB squared is equal to the change in x, which is 2 squared. And the change in y is minus 5 squared. So 2 squared is 4 and minus 5 squared is 25. 4 plus 25 is 29. So AB squared is equal to 29. As such, the length of AB, or modulus AB, mod AB is root 29. So if we want to find a unit vector of AB, it will be the vector AB divided by its length. So AB is equal to 2i minus 5j all over the square root of 29. Part 2. The acute angle AOB in degrees to 1 decimal place. So if we want to find the angle, we can use the scalar or dot product. And if we're using the dot product, we want to be using the angles either coming out from O or going into O. So either we're using OA dot OB or we're using AO dot BO. So let's use the first one. OA dot OB is equal to the length of OA times the length of OB cos theta. And we can substitute. We know OA is 3 minus 2 dot 5 minus 7 is equal to, we'll be using Pythagoras' theorem, and the length of it will be the square root of 3 squared plus minus 2 squared by OB, which is the square root of 5 squared plus minus 7 squared cos theta. There's only one unknown, which is theta, so we can solve for that. So if we're using the left hand side, it will be 3 times 5 plus minus 2 times minus 7 is equal to the square root of 3 squared is 9 plus minus 2 squared is 4. 9 and 4 is 13, square root of 13. And 5 squared is 25 plus 7 squared is 49, which is the square root of 74 cos theta. So if you want cos theta, it will be 3 5 are 15 plus 14 is 29. 29 over the square root of 3 by the square root of 74. As such, theta is equal to 20.8 degrees. May 2015, number 4a. The following diagram shows a circle of radius r is equal to 4 centimeters with center O and sector AOB, which subtends an angle theta is equal to pi on 6 radians at the center. If the area of the triangle AOB is equal to half r squared sine theta, then calculate the area of the shaded region. The area of the shaded region is the area of the entire sector minus the area of the triangle. And we know area of a sector is half r squared theta minus a half r squared sine theta. So we could factorize out the half r squared. So it's going to give us a half r squared theta minus sine theta. We can now substitute for r and theta. So the area of the shaded region is a half by 4 squared times pi on 6 minus sine pi on 6. And 4 squared is 16. So a half of 16 is 8 times pi on 6 minus sine pi on 6 is similar to sine of 30, which is equal to a half. So we can expand the bracket. So 8 pi on 6 is 4 pi on 3 minus 8 times a half is 4. Shaded area is 0.2 square centimeters. Part B. Solve the following equation giving your answer correct to 1 decimal place. 8 sine squared theta is equal to 5 minus 10 cos theta, where 0 degrees is less than or equal to theta, which is less than or equal to 360 degrees. So let's write the equation. 8 sine squared theta is equal to 5 minus 10 cos theta. And we know sine squared theta plus cos squared theta is equal to 1. So sine squared theta is equal to 1 minus cos squared theta. So we can substitute for that on the left hand side. So it's going to give us 8 by 1 minus cos squared theta is equal to 5 minus 10 cos theta. I'm going to expand the left hand side. So it's going to give us 8 times 1 is 8 minus 8 cos squared theta is equal to 5 minus 10 cos theta. And we can carry everything across to the right hand side. So we get 0 is equal to 8 cos squared theta minus 10 cos theta plus 5 minus 8. We can simplify that. So it's going to give us 0 is equal to 8 cos squared theta minus 10 cos theta minus 3. So we now have a quadratic, and we can factorize it. So 0 is equal to 2 cos theta minus 3 by 4 cos theta plus 1. This indicates that either the first brackets, 2 cos theta minus 3 is equal to 0, so 2 cos theta is equal to 3. As such, cos theta is equal to 3 on 2. And we know that the sine and cos graphs, the maximum and minimum values are plus and minus 1. So if we're getting 3 on 2, which is 1.5, that means theta is not possible. So since the first brackets cannot work out to be 0, then it's clear that only the second brackets can give us the 0 to solve the equation. So 4 cos theta plus 1 is equal to 0. 4 cos theta is equal to minus 1, which means cos theta is equal to minus 1/4, which indicates that theta is equal to cos inverse of minus 1/4. So theta is equal to 104.5 degrees or 255.5 degrees. Recall that if cos theta is negative, it means that the angles are either in the second quadrant or it's in the third quadrant. May 15, number 4C. Prove the identity sin theta plus sin 2 theta all over 1 plus cos theta plus cos 2 theta is equal to tan theta. So when we're proving trigonometric identities, I found it's easier for students if they take the more complicated side and work with it. So let's rewrite the left-hand side. So that's equal to sin theta plus sin 2 theta all over 1 plus cos theta plus cos 2 theta. And what can we do with this? Well, we have some double angles, so we can use the double angle formula and expand accordingly. So we can rewrite the numerator as sin theta plus, what is sin 2 theta? 2 sin theta cos theta, all over 1 plus cos theta plus, we have another double angle, cos 2 theta, and there are 3 different forms. So we're going to use 2 cos squared theta minus 1. As such, we can simplify the denominator, so we can rewrite it sin theta plus 2 sin theta cos theta, all over cos theta plus 2 cos squared theta. So now we can factorize the numerator and the denominator. So we can pull out sin theta from the numerator, so it's going to give us sin theta by 1 plus 2 cos theta. And in the denominator, we can factorize out the cos theta. So it's going to give us cos theta by 1 plus 2 cos theta. And since the brackets are the same, they can cancel out, so we're left with sin theta over cos theta, which is equal to tan theta. And as such, that's the right-hand side, so we have proven this trigonometric identity. May 2016, number 3A, part 1. The points M, 3, 2, so let's bring that up in a little sketch on the right-hand side, and N, minus 1, 4, let's also add that, are the ends of a diameter of a circle. So let's draw a line straight across to indicate such. So we have our diameter. Determine the equation of the circle C. Now we know the center of the circle will be the midpoint. And if we have M as 3, 2 and N as minus 1, 4, the midpoint will be the average of the X values and the average of the Y values. So that will give us 3 plus minus 1 all over 2 by 2 plus 4 all over 2. So 3 plus minus 1 is 2, 2 into 2, 1, and 2 plus 4 is 6, 2 into 6, 3. So we know the center. The center is 1, 3. Now r squared, which is the radius squared, is equal to change in x squared plus change in y squared. So if you want to find the radius, we can use Pythagoras' theorem and find the length of the radius. So the change in x, when we're moving from the center to the circumference, will be 2, and the change in y will be minus 1. So 2 squared is 4, plus minus 1 squared is 1, 4 plus 1 is 5. So r squared is equal to 5. As such, if we want to find the equation of the circle, then we can substitute into the general formula which is given in the formula sheet, x plus f all squared plus y plus g all squared is equal to r squared. And we know the center is 1, 3. If we're substituting for f, we'll say x minus 1 all squared plus y minus 3 all squared is equal to 5, because 5 is equal to r squared. And we can expand it, so we're going to get x squared minus 2x plus 1 plus y squared minus 6y plus 9 is equal to 5. And we can carry everything across on the left hand side and simplify, so we're going to get x squared minus 2x plus y squared minus 6y. 1 plus 9 is equal to 10, 10 minus 5 is 5, plus 5 is equal to 0. And that's the equation of the circle. Part 2, find the equation of the tangent to the circle at the point minus 1, 6. So let's bring up the point minus 1, 6. And notice that that is not even on the circle. So we cannot get the tangent to the circle at that point. So we believe there's a typographical error here, and the question should really be stating at the point minus 1, 4, which is n. So we're going to work it out as if it was at minus 1, 4 at n. And let's bring up a green line to indicate the tangent at that point. So if you want to work out such, remember that the question where it was at P cannot be found is an error. So let's work out the question as if it was at n. So the gradient of the radius, mr, is changing y over change in x, which was minus 1 over 2. We already used those values when we were finding r above. So we know the gradient of the radius is minus a half, and that makes sense because if we look at our graph, our blue line is sloping downwards. So our gradient is negative. And if we have two perpendicular lines, then the product of the gradients will be equal to minus 1. So you can say mr, the gradient of the radius, times mt, the gradient of the tangent, is equal to minus 1. And we can substitute minus a half times mt is equal to minus 1. So mt, the gradient of the tangent, is equal to 2. So mt is equal to change in y over change in x, and we can substitute to find the equation of a line. So that will be 2 is equal to y minus 4. We might be using a point on the line. In this case is n over x minus 1. So, and we can make y the subject of the formula. So let's carry the denominator across. We're going to get 2 times x plus 1 is equal to y minus 4. Let's expand and carry the minus 4 across. So it's going to give us 2x plus 2 plus 4 is equal to y. As such, the equation of that green line is y is equal to 2x plus 6. And if we check, we can tell that the gradient is 2, which is positive, and we can see the green line is sloping upwards to the right. May 2016, number 3b. The position vector of 2 points A and B relative to a fixed origin O are A and B respectively, where A is equal to 1, 2, and B is equal to minus 3, 5. So let's bring up a little sketch, putting O at the center, and if A is 1, 2, then let's bring up A at that point on the right, which will be in the first quadrant, and let's bring up B in the second quadrant. So we have two green lines indicating the vectors OA, or small a, and OB. P lies on AB such that PB is equal to 1/4 AB. So since we're looking at the vector AB, let's draw a red line to indicate that we're going from A to B. And PB is a quarter of that. So the length of it is a quarter of AB and closer to B. Or we can say that AP is 3/4 AB. Find the coordinates of OP. And there are multiple approaches to this, just like in every other question in math. So if we want to go from O to P, how can we pass? We can start at O and go to A, so that's OA, and then we can go from A to P. Another way of solving it, we could have started at O and go to B, OB, and then go from B to P. Either one will work. This gives us OP is equal to OA plus 3/4 AB, because we just spoke about the fact that AP is 3/4 of that length of AB. And what is AB? We can substitute for that. OP is equal to OA plus 3/4 of, how do you go from A to B? We go from A to O plus O to B. And we don't know AO, but we know opposite of it, which is OA. So let's substitute. OP is equal to OA plus 3/4 minus OA plus OB. Remember, the negative sign means that it's going in the opposite direction. And we can simplify there. So OP is equal to, we have 1 OA minus 3/4 OA, so that will give us 1/4 OA plus 3/4 OB. All we're doing is expanding the brackets and simplifying. And let's rewrite that. So we have OP is equal to 1/4 OA plus 3/4 OB, and we can substitute. So OP is equal to 1/4 of, what is OA? 1, 2, the x value is 1, the y value is 2, and the 3/4 minus 3, 5. And for simplicity, we can factorize out the quarter. So that will be left with 1, 2, plus 3 times minus 3, 5. So OP is equal to 1/4 of 1 plus 3 times minus 3 is minus 9. 1 minus 9 is minus 8. and 2 plus 3 5s are 15, 15 and 2 is 17. So OP would mean we're going a quarter times minus 8, 17. And if we look at our diagram, a quarter of minus 8 is minus 2. It means that we're going from O to P, we're going to the left 2 units, and then we're going upwards. May 2016, number 4A. The following diagram, not drawn to scale, shows two sectors, AOB, which is the smaller sector, and DOC, which is the larger sector. OB and OC are x centimeters and x plus 2 centimeters, respectively. And the angle for both of them, which is angle AOB, is equal to theta. If theta is equal to 2 pi or 9 radians, calculate the area of the shaded region in terms of x. So if we want to find the area of the shaded region, that would be the area of DOC minus area of AOB. And we can substitute for that. The area of the large sector would be a half r squared theta. Let's use a big R for that. Minus a half r squared theta for the small sector. And let's use a small r for that. Of course, we can now factorize out a half theta. So we're left with area of shaded region would be a half theta by r squared minus r squared. And we can substitute because we know theta and we know r in terms of x. So that will give us a half times 2 pi on 9 by x plus 2 squared minus x squared. And of course, we can now expand and simplify. So 2 cancels 2, so we're left with pi on 9. And then x plus 2 all squared is x squared plus 4x plus 4 minus x squared. And we can simplify, so we get pi on 9, and the x squareds cancel, so we're left with 4x plus 4. And of course, we can factorize out the 4. So the area of the shaded region is 4 pi on 9 by x plus 1 square centimeters. Part B. Given that cos 30 degrees is equal to root 3 on 2 and sine 45 degrees is equal to root 2 on 2, without the use of a calculator, evaluate cos 105 degrees in surd form, giving your answer in the simplest terms. And of course, just like every other topic in mathematics, there are multiple ways to solve this. So let's take cos 105, and that is equal to cos of 180 minus 75. And if we look at applying cos to two different angles, then we can apply the compound formula given in the formula sheet. And that formula says cos A cos B plus sin A sin B. So let's apply it here. So cos 105 is equal to cos 180 cos 75 plus sin 180 sin 75. And if you recall, and cos 180 is equal to minus 1, so minus 1 times cos 75 is equal to minus cos 75 plus sin 180, and sin 180 is equal to 0, so 0 times sin 75 is 0. So we now realize that cos 105 is equal to minus cos 75. And if you look at the information given above, we don't have 75, but we have 30 and 45. So we can now go and break it up again using the same compound angle formula. So cos 105 is equal to minus cos 30 plus 45. And let's separate it again. Let's leave the minus sign outside. So that gives us cos 30 cos 45 minus sin 30 sin 45. And if we redistribute the minus 1 across the brackets, then it's going to give us minus cos 30 cos 45 plus sin 30 sin 45. And we know all four items, so we can substitute. So we got cos 145 is equal to minus root 3 on 2 times root 2 on 2 plus sin 30 is a half root 2 on 2. And we can now factorize out root 2 from the numerator and 4 from the denominator. So cos 105 is equal to root 2 over 4 by minus root 3 plus 1. May 2016, number 4C. Prove the identity sin theta plus alpha all over cos theta cos alpha is equivalent to tan theta plus tan alpha. So when we're doing trigonometric identities, my students usually find it easier if we take the more complicated looking side and convert. So we'll deal with the left hand side, sin theta plus alpha all over cos theta cos alpha. If we look at the numerator, sin theta plus alpha, it looks like we can apply our compound angle formula. And remember, sine A plus B is equal to sine A cos B plus sine B cos A. Therefore, if we expand the numerator, it will give us sine theta cos alpha plus sine alpha cos theta, all over the denominator, cos theta cos alpha. And we can break it up into two separate fractions. So it will give us sine theta cos alpha all over cos theta cos alpha plus sine alpha cos theta cos alpha. Let's recall that trigonometric identities usually are very simple. After using our compound angle or double angle formulas accordingly, it simply becomes a practice in the use of fractions. So we separated them into two different fractions, and if we look at the one on the left hand side, we can see that cos alpha is in the numerator and denominator, so we can cancel them. So that leaves us with sine theta over cos theta. And we can see on the right hand side that cos theta is the same in both the numerator and denominator, so we can cancel those. So we're left with sine alpha cos alpha. And that gives us sine on cos is equal to tan theta plus tan alpha, which is equal to the right hand side. So we have completed the proof. We've now come to the end of CSEC past paper questions in section 2 of the syllabus, coordinate geometry, vectors and trigonometry. This is our first video in this section, and we looked at the past paper questions from 2012 until 2016. Our next video will be looking at the next 5 years past papers from 2017 until 2022. Feel free to look at the description down below, where we have identified the areas that you should follow in order to cover the entire syllabus.